Hi everyone, so today we will solve LeetCode 238. It's called product of array except self. And so in this question, we are given an integer array nums and an array answer. And we need to return the array answer such that answer of I is product of all elements of nums except nums of I. And we must solve this in big of N without using division operation. So coming to the first example, so we have 1, 2, 3, and 4. So if I index it, it's 0, 1, 2, 3. So answer would also be of same size, 0, 1, 2, 3. So what we want is answer of I. Suppose we talk about zero index. So answer of zero should be product of everything in nums except nums of zero. So we need to discard this nums of zero. So if we discard it, the remaining are 2, 3, and 4, and their product is 24. So that's why we have 24 here. Similarly, answer of 1 is product of everything except nums of 1. That means we need to discard 2 this time. So if we discarded 2, so what we would have is 1, 3, and 4, and their product is 12. Similarly, answer of 2 would be everything except nums of 2. Nums of 2 is 3. So except this 3, we need to product everything. That is 1 into 2 into 4, which is 8. And similarly, answer of 3 is product of everything except nums of 3. Nums of 3 is 4. So product of everything except this 4 is 1 into 2 into 3, which is 6. So this is why this is our answer array. So I hope the question is clear. So let's head over to the approach of solving this. So the very first or the naive solution would be, see, we can compute the product of all elements first. That is 1 into 2 into 3 into 4, which is nothing but 24. So it compute product of all elements. And while filling the answer array, what you would do is, see, at answer of 0, we want product of everything except nums of 0. So product of everything we already have. So answer of 0 would be, or in generic terms, answer of I would be product of everything we already have upon the current element, because we need to exclude this, right? So this is what we would use to fill our answer array. So product of everything is 24 and current is 1. So 24 by 1 is 24. Similarly, answer of I, that is answer of 1 would be product of everything, which is 24, we already have, upon the current thing. Current is 2, 24 by 2 is 12. Similarly, answer 2 is product of every element, which is 24, divided by the current element, because we want to exclude self. Self is 3, so that's why it's 8. And similarly here, we would get product of everything by self, which is 24 by 4, which is 6. So this is one way of doing this, but as you observe, we are using division operation in this, which is not allowed. So this is not the intended solution. So let me show you the intended solution and the approach. So I have written the test case again. So let me first generalize this thing. Suppose we have a big array nums, and suppose we are currently computing answer of I. Suppose I is this. So we need to find out what will be the answer of I. So as you know, this is nothing but product of every element in this nums array except this element, because we need to exclude the self. So which this is nothing but product of these elements and these elements. So this is 0, this would be I minus 1, because this is I, and this would be I plus 1. So answer of I, as you can see, is nothing but product of this portion, which is 0 till I minus 1, into product of this portion, which is product of I plus 1, and this is the last element, which is n minus 1. So this is what our answer of I would be. So this is product of 0 till I minus 1 into product of I plus 1 till n minus 1. So as you can see, in this way, we took these products and we excluded ourselves, which is exactly what we want. And we didn't use division operation anytime. So we would be there doing this only. So now suppose you do this process for this I. Now after some time you are computing for this I, suppose. So you would need product of here till here and product of here till here. So every time you would encounter a new I, you would not repeat this process of computing these two products of these two portions, right? Otherwise it would be n square in complexity. Because for every index I, you will be computing 0 till I minus 1 ka product and I plus 1 till n minus 1 ka product. So that would be hectic in time complexity. So and we want big of n solution. So we would be doing some pre-computation and we would solve this smartly. So let me show you what we would be doing. So in this thing, we would be taking two helper arrays, we would be making them. One would be prefix and the other would be suffix. These would store prefix products and suffix products. So let me tell you what I mean by that. So these size of these will also be same as that of the original array size. So let me index it. So see, let's first talk about the prefix. So prefix I would store nothing but product of 0 till I. That means it will store all the products from the starting till the ith index of which we are talking about. So if I say prefix of 2, it means nothing but product of all from 0 to 2. That is nums of 0 into nums of 1 into nums of 2. Simple. So this is what our prefix array will store. And similarly, talking about the suffix array. So suffix of I would store product of n minus 1 till I plus 1 or I. Sorry. So suffix of I will store product of n minus 1 till I. So if I say suffix of 1, so that means product of n minus 1 till 1. N minus 1, n here in our case is 4. Array size is 4, right? So n minus 1 would be 3. So that means product of 3 to 1, which is nothing but n of 3 into n of 2 into n of 1. Or equivalently, that order can also be changed because changing order doesn't change our results because multiplication is commutative. So I hope the meaning of both these are clear to you. So suffix would store product of n minus 1 till I and prefix would store product of 0 till I. So this thing is clear. So let me fill this. So prefix of 0 would store product of 0 till I. So currently I is 0 means product of 0 to 0, which is nothing but nums of 0 only. Because 0 to 0 means only 0 we are considering, 0th index. So this would have 1. Similarly, prefix of I would be 0 to I. That is 0 till 1 taka product. 0 till 1 means this thing. So it's 1 into 2. So it's 2. Similarly, prefix of 2 would be product of 0 to 2. 0 to 2 means this portion, this thing. So this has 1, 2, and 3. So their product is 6. Similarly, prefix of 3 means product of 0 to 3 index. That means nums of 0 into nums of 1 into nums of 2 into nums of 3. So this is 24. So this is our prefix array for this case. Similarly, talking about our suffix array. So prefix, as you saw, was filled from left to right, and suffix would be filled from right to left. So right to left means first you would fill this position. So suffix of 3. So suffix of 3 is by this formula, product of n minus 1. N minus 1 is also 3 here. So that means 3 till I. I is 3. It's nothing but nums of 3 only. So nums of 3 is 4. So we would put 4 here. Similarly, suffix of 2 is n minus 1. N minus 1 is 3 till I. I is 2. So 3 से 2 तक का product. 3 से 2 तक का product means this thing. So which has 4 into 3. That is 12. Similarly, suffix of 2, suffix of 1 is this portion's product. So which is 4 into 3 into 2, which is 24. And similarly, suffix of 0 means n minus 1, which is 3 till 0 तक का product, which means product of everything from n 3 to 0, which is 24. So this is our prefix and suffix arrays we would pre-compute. So let me clean this up and tell you what we would be doing further. So I've written the test case again. Suppose our nums array is this, and we are currently computing answer of I. So this would be I minus 1, this would be I plus 1, this is 0, and this is n minus 1. So as I told you, if we are computing answer of I, we would be needing product of these two portions. So this is nothing but product of 0 till I minus 1, right? So this is 0 till I minus 1. Into, we would be doing product of this portion. This portion is I plus 1 till n minus 1. That means product of I plus 1 till n minus 1. So what we saw that is answer of I would be nothing but product of 0 till I minus 1 into product of I plus 1 till n minus 1. And this can also be written in reverse order because product is commutative, right? So 2 into 3 is equal to 3 into 2 only. So that's why let's write it in the opposite way. So it's n minus 1 to I plus 1. So, and let me also write the formula for prefix we wrote before. So prefix of I was nothing but product of 0 till I, right? And suffix of I was product of n minus 1 to I. So if we compare these carefully, this is product of 0 to I minus 1. So 0 to I minus 1 means this falls in the category of prefix because it starts with 0. So product of 0 to I minus 1 is nothing but prefix of I minus 1. You can cross check. Prefix of I means product of 0 to I. So prefix of I minus 1 would mean product of 0 to I minus 1. So that's why this thing is replaced by prefix of I minus 1. Similarly, this thing is replaced by this starts from n minus 1 till I plus 1. N minus 1 means suffix. This falls in the suffix category. So suffix of I meant product of n minus 1 till I. So product of n minus 1 till I plus 1 would be suffix of I plus 1. It's exactly same, just I is replaced by I plus 1 in suffix here, and I is replaced here by I minus 1 in prefix. So these two things we got. So for when we would compute the answer of I, we would do nothing but prefix of I minus 1 into suffix of I plus 1 every time. So this would give our result. So as we discussed, the answer of I at any instant would be prefix of I minus 1 into suffix of I plus 1. Also, one more thing, suppose we will do this thing for every I. So we will prefix of I means 0 till n I minus 1 product, right? And suffix of I plus 1 means n minus 1 till I plus 1 of product. So for every I, we would not, repeatedly traverse from 0 till I minus 1. And for next I, we would also do this. This thing we would not do. Otherwise, what's the point of pre-computation, right? So we would fill these arrays smartly, our helper arrays smartly. So let me show you how we would fill these. So suppose, let's talk about prefix first. So prefix does nothing, but it stores. Suppose we talk about prefix of I. Prefix I stores product of 0 till I, right? That means this is 0. So this means, right, 0 till I means this portion. So prefix I stores this. And this we would prefix array, as we know, we fill from left to right. So if we are currently tackling with an index I, we would already have the results for these places because we came from there only, left to right. So for prefix I, what we would do is, see, हमें यहाँ से यहाँ तक को product चाहिए in prefix I. So यहाँ से यहाँ तक product, that is 0 से I तक का product, can be easily determined if we have 0 to I minus 1 product and we just multiply this portion's product into this element. So what I'm saying is, if I want these 0 to I taka product, and I already would be having hair to hair product, that is 0 to I minus 1 taka product, because we have come from left to right. So if we are at here, we would already have answer for this. So यहाँ से यहाँ तक product we already have stored in this. We would just multiply this quantity with current num, and we would get the bigger product ultimately. So that's what I'm saying is that prefix of I would be nothing but prefix of I minus 1 into current number. This is becomes a formula for a prefix array. Similarly, for suffix also, let's say we talk about this index I. So suffix, as I told you, was n minus 1 till I. The suffix of I meant n minus 1 till I taka product. N minus 1 is this. So if we talk about suffix of I, this means n minus 1 till I taka product, that is this portion's product. And suffix is filled from right to left. So we want this thing's product, and we would fill this, that thing is in this place. So since we are traversing from left to right, we would also already have answers for these things. So for to tell product of this to this, if we already have this to this product, that is I plus 1 till n minus 1 taka product we already have. So we would just multiply this number with this product and we would ultimately get the bigger product. So what I'm saying is suffix of I would be suffix of I plus 1 into current number, that is nums of I. So this becomes the formula for our suffix array. So this is for prefix and this is for suffix. So I hope this is clear. So we would be doing this only. And also prefix of 0 would be prefix of I is what is prefix of I? It's nothing but product of 0 till I. But here I is also 0. That means 0 to 0, which is nothing but nums of 0 only. So prefix of 0 is nothing but nums of 0 only. Similarly, suffix of n minus 1. Suffix of I was what? It was product of n minus 1 till I. So suffix of n minus 1 would be product of n minus 1 till n minus 1, because I is the n minus 1 here only, which is nothing but nums of n minus 1. So suffix of n minus 1 would be nums of n minus 1 and prefix of 0 would be nums of 0. So these two things we would already initialize first and then we would fill the rest of the arrays. So let me write the code for it so things will become much more clearer. So I've written the code. So we would be returning an integer array. It would we would return an integer array and we have in nums array as our input. So we compute nums length and we declare two arrays, prefix and suffix. And as I told you, prefix of 0 is initialized as nums of 0 and suffix n minus 1 is initialized as nums of n minus 1. So in these two loops, we fill our prefix and suffix arrays as I told you. Let me tell you for prefix, I am telling you again. So suppose we are at index I. So prefix I means यहाँ से यहाँ तक का पूरा product. That is from 0 to I. So since we are filling it from left to right, so you would already have this portion's product. That is 0 to I minus 1. That would be stored in prefix of I minus 1 only. So we already have this product. So to get the bigger product, we just need to multiply this product into this element, this thing. So that's why we did prefix of I is nothing but prefix of I minus 1 into the remaining element, that is current element. And similarly, we did for suffix also. So this is how we compute our prefix and suffix arrays. Then we declare our answer array, and answer 0 and answer minus 1 are previously filled with suffix of 1 and prefix of n minus 2. Let me explain you this also. So suppose our nums is something like this. So answer 0 means uh, here till here product, that is 1 till end. So 1 till end means nothing but 1 till end. End is n minus 1. So this is nothing, if we reverse it, it is n minus 1 till 1, which is nothing but suffix of 1 only, right? So that's why answer of 0 is suffix of 1. And similarly, answer of n minus 1 means, let me erase this thing. So n minus 1 means, except for n minus 1, include everything in our product. That means include this, and this. That means answer of n minus 1 is this. 0 से 2 तक का product. 0 से 2 तक का product. And this is nothing but prefix of 2. So that's why, sorry, prefix of n minus 2. Here it is coincidentally true. It's 2 here, but it would be n minus 2. Since apart from n minus 1, we want product of everything starting from 0, 0 till n minus 2. So that's why we filled answer of n minus 1 with prefix of n minus 2. And for the remaining cases, that is for 0 and n minus 1, we already did. So remaining are 1 till n minus 2. For remaining, we to apply a formula, that is answer of I is prefix of I minus 1 into suffix of I plus 1. See, for 0 and n minus 1, we calculated separately because suppose here we are using I minus 1, right? Suppose here we started from instead of 1, 0. Then we would do I minus 1, which is 0 minus 1, which is minus 1, which would result in array index out of bound, right? So that's why you know, to prevent that, we already did for 0 and n minus 1. Similarly, if I was n minus 1, like here, so n minus 1 plus 1 would be n. This would also give array index out of bound because indexing is from 0 to n minus 1 because indexing is 0 based. So minus 1 and n would not be present in our, would give array index out of bounds. That's why we handled these two cases separately. So this way we fill our answer array and finally return it. So this was our approach. So coming to the time and space complexity of this. So time complexity, here we are doing big of n, here also big of n, here also big of n. So time complexity is nothing but big of 3n, which is asymptotically equal to big of n only. And space complexity, we have used two arrays of size n each. So it's size taken by prefix array, that is n, plus that taken by suffix array. So it's true n, which again is asymptotically equal to n only. So time and space both in our case is big of n. And this is the intended solution for our problem. So I hope you liked the question and understood it properly. So yeah, that's it for today's video. Thank you so much for watching.